right. Oh yeah, we gotta go back to that one. All right, so let's. So what do I need to do first on this one? Well, I don't know the answer. Distribute. Okay, so we're gonna distribute on this side. So that's gonna give us 2x plus 3. Let me find a marker I like. All right, so we get 2x plus 6, right? All right, so when I distribute the 2 to the x plus 3, I get 2x plus 6, right? The minus 5 just gets brought down. Then I go negative 3 times 2x gives me negative 6x. Negative 3 times 3 gives me negative 9. And then the minus 1 gets brought down, right? Okay, so what I like to do on each side is I just like to highlight my like terms. Okay, those are like terms. Those are like terms, right? Things that are like terms get combined. So what are those going to turn into? What's this going to turn into? Plus 1. And what are these going to get turned into? Negative 10. Okay. Now what are you going to do? Okay, so plus 10 here. And I got to add it to a like term over here, right? So it gives me 2x plus 11 equals negative 6x. Now what are you going to do? Okay, so it's going to minus 2x. Minus, what's negative 6x minus 2x? Careful. If you're $6 in the hole and you borrow $2 more from somebody, how many dollars are you in the hole? You're 8 in the hole. So negative 6, and that's something. That's why I tell people to be cautious on if you've got variables that are negative, moving them all to that side, because a lot of times people run into that subtracting a negative. So that's negative 8x. Now you're going to divide both sides by negative 8, right? So it gives you negative 11/8 is equal to x. Good. Okay. What I think is like at this stage here, where you added 10, because I see the x being negative, I'm going to, so I had what, 2x plus 1 equals negative 6x plus minus 10. I would add 6x to both sides and get my 8x plus 1 equals negative 10. Then subtract 1. You still have to do subtraction of negatives, but negative 10 minus 1 might be maybe mentally a little bit easier to do. I don't know. So that still gives you negative 11/8. All right? All right, let's go down to these story problems. You guys like story problems? Why do you hate them? Because there's no pictures? All right, two buses. Two buses leave Houston at the same time and travel in opposite directions. Okay? It says one bus averages 55 miles per hour and the other bus averages 45 miles per hour. When will they be 400 miles apart? Okay, so when we come across story problems, guys, I think the best thing to do, draw a picture first. Okay? So draw a picture. So we've got, let's just say Houston is here in the middle. We're going to have one car traveling that way, and we're going to have one car traveling that way, right? Okay? I guess buses. It says one bus averages 55 miles per hour. So I'm going to just say, like, bus 1 over here is 55 miles per hour. I'm going to call that R. Stands for rate, right? Okay. Bus 2 over here, okay, it's traveling at 45 miles per hour. Okay. The question at hand is, when will they be 400 miles apart from one another? Okay. So, right now, the question says when, right? So that's kind of our unknown. We don't know when. Okay. So I'm going to just say that the when is our variable t for time. Okay? What do you guys know about distance and rate and time? Close. Rate times time. So distance equals rate times time. So right now, I have a rate here, correct, for bus number 1. And I have a rate for bus number 2. If I think about adding those together, don't do this yet, but if I added those two, bus 1 and bus 2 together, their distances traveled, shouldn't that equal 400 when I'm done? If they're going to be 400 units apart or miles apart, does that make sense? Okay, but I can't add a rate and equal a distance. Does that make sense? A distance plus a distance has to equal a distance. Is everybody okay with that idea? So these are rates. And because of this formula, I can change them into a distance. I can say 55 times the time. So my distance is rate times time. Here's my rate. Multiply it by a time. And now that expression, 55t, expresses the distance traveled by bus 1. And I just don't know what t is. If t was 1, it'd be 55 miles. If t was 2, it's 110 miles. Does that kind of make sense?
Yep.
Okay. So I have to be able to take the information they give me and compare it to this distance. Okay, so this needs to be a distance as well. So that distance, you don't need to write d equals 55 times t, but I just wanted to remind ourselves that that's distance. So I can do the same thing over here. This distance traveled by bus 2 would be 45 miles per hour times however many hours it's been traveling. So times t again. So my hope is now that it makes sense that the distance traveled by bus 1, which we call 55t, plus the distance traveled by bus 2, those should be how far apart from one another? 400. What is 55 plus 45? 100. So we get 100t is equal to 400. So t is equal to what? 4. And all my units were miles per hour, right? So it's 4 hours in this case. So it takes 4 hours for them to become 100 miles apart. I don't know. Sometimes I like making that little one there at the bottom, but... Huh? We just talked through why. And I'll take your 4 and plug it back into 55 miles per hour. What's 55 times 4? What's 50 times 4? 200. What's 5 times 4? 20, right? So 55 times 4 is 220, correct? Keep that number in mind. What's 45 times 4? What's 45 times 2? 90. What's 90 times 2? 180. So bus 1 traveled 220 miles in 4 hours. Bus 2 traveled 180 miles in 2 hours. Or sorry, 4 hours. What's 220 plus 180? 400, right? So we could check that. We can find the specific distances that those buses traveled and then add them together and see that their distance does total 200. Okay? We do the same thing down here. It says 2 planes left an airport at noon. One flew east and one flew west. Okay, do you know how fast they flew? Nope. Okay, I'm going to call this one east. This one west. Okay. One flew east and the other one flew west at twice the speed. Which one do you know least amount about? Or which one do they tell you the most about? Okay, the one that's going west, they tell you is twice something else, right? So that one they've given you the more data about, more information about. So the one that's going to the east, we know nothing about its speed. So let's just say its speed is r. Does that make sense? You always let the thing that you know the least, like let's say I've got a brother, okay? My brother is 6 years older than me. Which person do you know more information about in regards to the age, me or my brother? My brother. I told you more about his age, right? Now, you still don't know either of them, but you know more about him than you do me right now. Okay, same thing here. Okay, so if that eastwardly traveling plane is R, this one is twice R, right? That makes sense? So those are rates. It says after 3 hours, the planes are 2,700 miles apart. That's a distance, right? Okay. It says how fast was each plane flying? Now, I've got a distance. I've got a total here of 2,700. And I've got 2R and I've got R. Can I add two rates together? Can I take 2R plus R and set that equal to a distance? Does a rate plus a rate equal a distance? No, a rate plus a rate should equal a rate, right? So if I've got this distance, okay, there's a couple different things we can do here, but I think it probably makes most sense kind of keeping in line with the last one we did. Let's change this rate to a distance. How long were these planes flying? 3 hours. So that's a time, right? If I multiply that by 3, and I multiply that by 3, that gives me 6R plus 3R, right? And those are distances now, is equal to 2,700, which is also a distance. So we get 9 R's, 2,700. R then is, what's 27 divided by 9? 3, so we got 300. So my rate is 300. That kind of make sense? So plane traveling towards the east, which we defined it as R, is traveling at 300 miles per hour. Plane going towards the west, traveling at 600 miles per hour. Is that something we can do? What if we did it this way? Let's say, because you can do this, we said initially this was R and 2R, and they were both rates, right? And this was a distance. So we initially took like 2R plus R and said, well, that equals 2,700. Well, that's a rate plus a rate equals a distance. So we can't do that. Can I take this distance? We know distance is equal to rate times time, right? Can I take and divide by time here? Those are going to cancel. Leave me distance divided by time is equal to a rate. Can I take that 2,700 divided by a time? What time would we choose here? 3 hours, right? What's 2,700 divided by 3? 900, right? So now I've taken the 2,700 and the 3 hour components, changed those to a rate. Now I get 3 R's is equal to 900. What's that going to be? R is going to be 300 again, right? A lot, especially story problems, there's a lot of times that you can approach them in different perspectives, different routes, okay? I just want you guys to know, and mathematics, I think it's beaten into you when you're younger. You got to do it this way. You got to do it this way. You got to do it this way. There's more than one way of doing things, and I'm going to try to open your eyes to those things. I think it's very important to see that we've got multiple ways of doing something. The length of a rectangle is 3 centimeters greater than its width. Which one of those things do you know the most about, the rectangle's width or length? You know more about the length, right? It says the length is 3 centimeters greater, okay? So what I'm going to do is and we should have probably done this in the previous questions, but our pictures kind of took the place of this. I'm going to identify my variables. I'm going to say that I'm going to let, a lot of times the way you do this, you say let, like W equal width. That's the thing we know the least amount about, right? Okay? You don't need to write this, but I'm going to say variable. We know least amount about. And then I want to write my length, and I want to try to write my length without introducing a new variable. So can I use W to write my length? And that's really what you want to try to do. Every time you come across a story problem and you're trying to create variables, you want to try to minimize the number of variables you use, because if you can do that, it makes the solving easier. If I just say, well, length is L here, Okay, there's nothing wrong with that, but I'm not going to be able to solve this problem using that. Okay, so I want to try to use variables that I've already created. So how can I show what my length is knowing what my width is, W? Jenna? Width plus 3. So W plus 3 would be my length. Okay. So we got that. Now we've got to look at what we mean by perimeter. What's perimeter mean for a rectangle? Okay, so in general, you have two widths. Well, let's do it this way. You have a width, a length, and a length, right? And perimeter is usually 2 of your L's plus 2 of your W's, right? Okay. But what did we just say our length was? W plus 3. So I'm going to rewrite this as, instead of L and L, I'm going to go W plus 3, W plus 3. So now I have 2 of those, right? So I should have W plus 3. There are 2 W plus 3s and 2 W's. Is that okay with everybody? So your perimeter, which they say has to be 24, is equal to 2 of my lengths, which are W plus 3, plus 2 of my widths. Some of you might be more along the lines and say, okay, I don't want to use that, and I just want to say perimeter is the distance of adding all the way around, right? So you might be a person that says, well, I'm going to say 24 is equal to W plus W plus 3 plus another W plus then a W plus 3 gets me back to where I started. So I've added all the sides up, right? Can we do that? Either route should give me, if I distribute, that gives me 2W plus 6 plus 2W, right? So how many W's you got total here? 4? How many W's we got down here? 4, right? So regardless of the technique you want to use the general rectangle formula for perimeter, that's fine. Or if you just want to use the concept of perimeter being the sum of all your side lengths, that's fine as well. And then I have what, plus 6? So then we're going to subtract 6 from both sides. This gives me 18 is equal to 4W. W then is equal to 18 over 4. Reduces to 9 over 2, which is, if we write it as a decimal, 9 over 2 is 4.5, right? So that's W, that's my width, right? So width, 4.5. Length, we said was 3 more than that, right? So your length should be 7.5. Does that make sense? Is that, do I ask for the areas? So, okay, next question. What is how do I find the area of a rectangle? Length times width. So I'm going to take 4.5 times 7.5, which 4 times 7 is what? 28? And a half times a half is 0.25. Okay, so let's see here. Where's my... Oh, wrong side of the screen. So we were looking at, what, 4.5 times 7.5? 33.75. Okay. I'll give you like, my goal for you guys is not necessarily to master every single story problem we come across, but at the same time, because I know just my personal experience, if I was in a math class, I'm hoping that my teacher never, ever, ever gives me a story problem. I hated them. Okay. But if I completely avoid them all the time, do I ever get better at them? No. Okay. I told my last class that the enemy of comfort is the enemy of progress. So to maintain that comfort, I didn't want my teacher to give me story problems, but then I never got better at them. Okay, so I try to find like a happy medium. I still present you some, but not overwhelm you with them to the point where you start hating the class because of them. Okay. Talk about these real quick, because we actually were using some of these inside those last three story problems. Okay. They're called literal equations. Okay. Basically, a literal equation is an equation that has multiple variables in them. A lot of times, they are formulas. Okay. And a lot of these things up there you see as formulas. That first formula, do we know what that first box is a formula for? Area of a triangle. Okay. That second box is it has to do with how objects fall, okay, based off of gravity. Okay. There's a lot of times where we're working, if we go down to that one in the bottom right, okay, 2 pi r squared plus 2 pi r h, that's finding the surface area of a cylinder. Okay. This one has something to do with I forget what that one's about. I think it's I could be completely wrong. But usually when you have R1 and R2, it's talking about annuluses, which is a shape like a donut, where R1 is the inside and R2 is that one. But I'm not sure if that has anything to do. I have to look it up. But what we want to do with literal equations is we want to isolate a particular variable. Okay. So in this first one, we want to isolate h. We want to solve for h. So what we need to do is try to get everything else away from it. Okay. So the way we want to think about this is how are 1/2 and b stuck to h, and then how do we unstick them? Does that make sense? So how is 1/2 and b stuck to h? What operation? Multiplication. How do we undo multiplication? Division. Okay, so if I divide by, so here's what I know you were taught in other classes this. I think you're taught at a younger grade. It's like if you have like something like this, these are stuck together through multiplication, right? 2/3 and x. Were you guys taught to divide by 2/3? I get a lot of people to give me the answer. I ask them, how do I get these unstuck? Or what do I need to do to both sides to get this to be, essentially we're trying to get this to be a 1x. And they'll say divide by whatever that is, no matter what it is. Because if it was like 3x equals 4, you automatically divide by that number out there, right? So when they see a fraction, they think automatically I need to divide by that fraction, which is not wrong. It works. But dividing by a fraction is the same as multiplying by its close reciprocal. Okay, like if I take a sandwich and I want to, and it's kind of weird to think about, but I want to take a sandwich and I want to divide it by a half, I'm actually going to multiply, instead of doing that, I'm going to multiply it by 2. Okay, and I actually have 2 sandwiches. It's kind of weird, but when we're trying to undo a fraction, we want to multiply it by its reciprocal. So if I multiply the right-hand side by 2 over 1, those are going to cancel away. Does that make sense? And I got to do the same thing over here. So I get 2a is equal to b times h. Is that all right? Now, how are b and h stuck together? Multiplication, and I undo that through division. Those are going to cancel. B over b is just 1, right? So I get 2a over b is equal to h. And that's my solution. Okay. Now, what we can do is we can actually create spam. Well, then they should call me from a number that isn't spam. If we want to figure out if this is done correctly, we can choose some variable. We can take A, we can take B, and we take H, and let them be numbers. Okay, so this is the way we have to do this, because we start off with this side here, right? So we're going to choose those numbers. We're going to choose the side that is just a little bit more complicated. So give me a number for B. Not what you're thinking, though, Austin. All right, so B is 60. Give me a number. Let's go 3 for H. Okay. So what's 60 times 3? Well, 180. What's half of 180? 90, right? You see how when I chose these numbers, I'm able to figure out what that number is, right? Okay. Let's take those numbers then and plug them in here and see if we get a true statement. So I get 2 times A. What's 2 times 90? Divided by B, which would be 60. That's 180 divided by 60. That's 18 divided by 6, which turns into 3, which is the H, which is what we chose as H earlier, right? That kind of make sense? Now, I do that by hand, but you can do it here as well. Okay, so I'm going to write my A equals 1/2 BH. Okay. So A, I'm actually looking for. But B, what did we say? B was 60. H was 30. Oh, H was 3. Sorry. Thank you. I know. All right, so that gave us those values of 90, 60, and 3, right? So then all we have to do, if we think we've done things correctly, we type in this side here, 2A over B. So 2A and then divide by B. Does that equal the H that was up here? Does it equal that 3? And it does. So you can use, and maybe that, I like the calculator because it creates, or eliminates the potential of me having errors in my substitution, that kind of stuff. Okay, so let's do this one. Let's solve for G. You guys do this one on your own real quick. Get G all by itself. See what you get. Is this similar to the last one where we multiply both sides by 2 first to get rid of the fraction? I think whenever you have fractions, important to get rid of them right away. So we'll multiply by 2, so it turns into 2 S's is equal to G T squared. Okay, how do I get my G by itself? Good, so divide by T squared, those will cancel. Divide by T squared, so I get 2S over T squared is equal to G. Oh, we got some more here. All right, so this one's a little bit more difficult. Let's solve for capital R. We'll do that first. It should be pretty easy to solve for capital R. How is capital R stuck to this thing here? Multiplication. So what I need you guys to understand is that when something's in parentheses, it is an entire object. Does that make sense? So we could just view that right now as just a singular number. And if I want to get a singular variable, and if I want to get the capital R by itself, I just need to get that to the other side, right? So can I divide by that sum? R1 plus R2? Because think about it. If R1 R1 was like 2 and R2 was like 5, wouldn't this number be 7? And you'd have like 7 times R. And how do I solve for capital R? I divide by 7, right? But in this case, because I don't know what numbers actually make that sum up, I'm just going to divide by the way it's written, R1 plus R2. Those will cancel. Come over here and do the same thing, R1 plus R2. So I get capital R is equal to R1, R2 divided by R1 plus R2. No. We could do it. So we could solve this for R1 or R2. Let's actually save that for another time. Let's come down. Let's skip that one too. Actually, let's do this one. This one's pretty quick. So we'll solve for H. Okay? And there are things stuck to it. But before I do division, think about how you solve normal equations. When I solve a normal equation, isn't the last step the division or the multiplication? Like I'll move all my constants, all my non-variable terms to one side. So if I had something, let's say we had like 5 is equal to 2 times 3 plus 2x. Wouldn't I move that to the other side before I divided by that 2? Does that make sense? Okay, we need to isolate the variable part that we're interested in. So that's the same thing here. We need to isolate that term first before we can even isolate the variable. So let's get this thing, the 2 pi r squared, to that side. So how do I get that to move across to the other side? Remember here, r is going to be a number, pi is a number, so this is just a numerical value. I want to move this thing over. Subtract it. So we get s minus 2 pi r squared should now equal 2 pi rh. Now, I've isolated the term that has my variable in it. Now I need to isolate that variable. This, remember, 2 pi is a number. It's like 6.28 something. And then r is going to be another number. So this is just a coefficient for h. Does that make sense? So let's say this was like 10h. If that was 10h, how would you get h by itself? Divide by 10, right? So now, instead of it being 10, it's 2 pi r. Let's divide by 2 pi r. Those cancel. Come over here. Divide by 2 pi r. So it ends up giving us s minus 2 pi r squared over 2 pi r is equal to our h. So the benefit of being able to do this is, so this formula is the surface area of a cylinder and allows you to find the surface area. So surface area is like if you had a cylinder, you go paint every part of it, right? Paint all the outside. That formula will allow you to do that if you know R and you know H. R being the radius of the cylinder or the circles on top, and H being the height of the cylinder. Okay? Well, let's say that I have a problem, a repetitive problem, that keeps saying, okay, I give you a bunch of these cylinders and I tell you what the surface area and the radius of all these cylinders are, but I ask you to find the height. Well, you could go through this form, you could plug in surface area and radius and go through this process for each one. Let's say I have you do this 10 times, and you go through that algebra 10 times to find that H each time. Okay? Or you can take this general formula here, rewrite it this way, and now take the numbers I gave you for surface area S and radius R and plug them in those 3 spots. Evaluate, and you get your height automatically. Does that make sense? So literal equations are allowing you to when you come to a situation where you have to repeat a process over and over and over again that might be time consuming with a formula, you can actually solve a formula for a different variable that maybe you're more interested in for that situation. All our formulas are that way. Okay, distance equals rate times time. Sometimes we're interested in time. Sometimes we're interested in rate. It's presented as distance equals rate times time because that's the one we're usually interested in, distance. But we can manipulate these things as we need to. Okay. There is an assignment on Math Excel. I opened it yesterday. It's going to be due. Told you yesterday I'd make it due Thursday. Okay. So just make sure you get to working on that. Tomorrow my plan is to see what we can get through with 1.5. No, you don't have your phone out, do you? Yeah, you liar. He says no and turns and shows it to me. So we'll start 1.5 tomorrow. Make sure you get 1.4 started and worked on in your homework, and we'll go from there.